This is the start of mechanics. It's quite a long topic, 17 hours. We're going to look at the first part, which is the first part of kinematics. Define displacement, velocity, speed and acceleration. Displacement. This is a distance moved in a particular direction from a fixed point. So it is direction and distance. Velocity is the rate of change of displacement. In other words, how the displacement changes with respect to time. Speed. This is the rate of change of distance. In other words, it's the total distance travelled divided by the time taken. And we can show the difference between velocity and speed here. This ball, this little blue circle, is going to do a quick trip. It goes all the way around there and back to the same place again. So to find its velocity and its speed, we need to look at its displacement and its distance. Now the displacement now is 0. It ends up in the same place that it started at. So its average velocity is going to be 0. Its speed, however, is the distance that it travels to go all the way around, divided by the time taken. So velocity and speed are not always numerically the same thing. Acceleration. This is the rate of change of velocity. In circular motion, we also have acceleration because the velocity, or rather the direction, is changing. Notice that we have displacement, velocity and acceleration in red. These are vectors. Speed is a scalar as well as a distance. Explain the difference between instantaneous and average values of speed, velocity and acceleration. Well, here we have a graph of distance against time, and we have a curve to show how the distance varies with time. So what is the velocity doing along these different parts of this curve? So this is the velocity is how much distance changes with time. Here's the distance and here's the time. How does one change with the other? At different parts of the graph there is a different velocity because it's changing at different rates. In other words, the gradient is changing. The average velocity is going to be the total distance, the total displacement travelled in the time taken. But let's say we want to find the velocity here. We have to basically find out what is the gradient at that point. The change in x divided by the change in t, which gives us the velocity at that point. That's the instantaneous velocity at that point in time. What about the velocity here? Here again, we must draw the tangent, draw a triangle, find the change in x, find the change in t. So this speed will be delta x by delta t, which will be a different gradient, and therefore it will be a different velocity. Here we have an example. The first one is the change in distance divided by change in time, 40 divided by 2, which will be 20 meters per second. The next one should, by the way, be 20 meters divided by 4 seconds, not 40 seconds. So it's 20 divided by 4 gives us 5 meters per second. Now, we need to outline the conditions under which the equations of uniformly accelerated motion may be applied. And we will be looking at these equations next. So uniform accelerated motion means that the acceleration is uniform. It's the same magnitude and the same direction. So the acceleration is constant. It can be 0, or it can have a fixed value, like 10 meters per second squared. If the acceleration is constant, then the force causing the acceleration must also be constant, which means also that the mass of the object must be constant. If the mass changes with the same force, you will get different acceleration, so the mass can't be changing. Now, we need to identify the acceleration of a body falling in a vacuum near the Earth's surface with acceleration g of free fall. What is acceleration of free fall? Near to the Earth, it's about 9.81 meters per second squared, or you could say roughly 10 meters per second squared. This means that every second its speed increases in the vertical direction by 9.81 meters per second. So after 1 second it's going at 9.81. After 2 seconds it's going at twice that. If you look on the YouTube after this and look for monkey and hunter experiment, this is a way of looking at vertical and horizontal components of velocity, how the vertical component is affected by gravity, how the horizontal component isn't. So here we have a way of looking at acceleration. The speed to start with is 0. After 1 second it's going to be roughly 10 meters per second. The next second it goes another 10 meters per second. The next second it goes another 10 meters per second. So you see that for every second it gets 10 meters per second faster. So in other words, acceleration is 10 meters per second per second. But then we have to think about what is the distance travelled. This is going to go up very rapidly because not only is the speed going up, it means that it's going to be covering more distance, so the total distance will be very much greater. So to start with, it's 0. After 1 second it's going to be 5, basically because during that 1 second by then it's travelling at 10, the average will be 5. By the end of 2 seconds it's going at 20 meters per second. The average speed is 10 meters per second and it's travelled for 2 seconds. But you notice that the distance travelled increases very rapidly. Now we have to look at the horizontal and vertical components. Now let's take the horizontal component. You notice that the distances are equal steps apart with time. So horizontally the ball travels at a constant velocity, so at each second it travels the same distance. Vertically, however, every second it accelerates, so each second travels a further distance. So if we actually have a body which is undergoing vertical acceleration and horizontal motion, you're going to get a curve which looks like this. Notice vertically it accelerates, horizontally it stays at the same speed, and this is a characteristic curve of projectile motion. And here we have a similar thing here. Horizontally, each ball, we have 3 balls here which are travelling at different speeds, and therefore they're going to cover different distances. However, vertically, all balls are going to accelerate at the same rate, independent of what their horizontal speed is. See, vertically, they drop at the same rate. Horizontally, the ones that are moving fastest are going to travel furthest. Ball 3 travels the furthest from the table because it has the greatest horizontal velocity.